Hey all, it's Miss Gross here. We're working on lesson 5, the size of a scale factor. Our learning target is I can describe the effect on a scaled copy when I use a scale factor that is greater than 1, less than 1, or equal to 1. Before we get started, make sure that you have lesson 5 paper going in your red notebook. Let's go ahead and get started. The size of a scale factor. When a figure is scaled by when this figure is scaled by the original, the scale factor greater than 1, the copy is going to be larger than the original. Because again, scale factor is multiplication. So if you're multiplying by greater than 1, then the copy has to be bigger because it's going to be times more than 1. Okay? A scale factor that is less than 1, the copy is going to be smaller. And that makes sense because any number less than 1 would be a decimal or a fraction, and so it would make it smaller. And a scale factor that is exactly the size of 1 would be the exact same size of the original because, again, anytime you multiply by 1, you get the exact same number. Pause this video to write this down, and then we'll go on to the next slide. Okay, the next slide is larger, smaller, or the same. So let's look at these two triangles. If we were to scale triangle ABC with a scale factor of 3/2, we would get a larger scaled copy because 3/2 is bigger than 1. 3/2 is 1 and 1/2. Okay, so that would be bigger than 1, so it would be a larger scale copy. The scaling of triangle DEF can be reversed using the reciprocal of the factor. So if we flipped the fraction and did, instead of 3/2, did 2/3, then that would be the backwards. That's how you could reverse it. So if you were saying that this one, DEF, was the original, and we wanted to know this one, the smaller version, you would say that this smaller version is 2/3 of the bigger one. And the bigger one is 3/2 of the smaller one. I hope that makes sense. Pause the video if you need to get these down before we move on to the next slide. In our final slide, we have got an example, square A and square B. Let's go ahead and put this in here. There's the B. There's square A, there's square B. If we scale square A using a scale factor of 4 to create square B, then we could scale square B using the reciprocal, and the reciprocal of 4/1 or 4 would be 1/4. So we could use the reciprocal scale factor of 1/4 to create scale A. So the way I would read this is A is 1/4 of B. B is 4 times bigger than A. Square B is larger scaled copy of square A, and square A is a larger scaled copy of square B. Pause this video if you need to get in and down any of the answers, and as always, ask me questions if you have any questions. Have a great rest of your day.